Hello everyone, I'm Brandon Ordoñez from ECE41 and today I will be performing our experiment number 7 for our Internet of Things laboratory, which is entitled Two-Way and One-Way Traffic Light System with Pedestrian Button using Raspberry Pi. Hello everyone, so now let us begin with our experiment. So for the first part of our experiment, we would input this code in Tori Python in our Raspberry Pi 4, and afterwards I will show you the circuit assembly here. So first, for the circuit assembly, let's open it using Fritzing. So for the circuit assembly, I've inserted 3 LEDs, different colored. Red, yellow, and green all represent the lights in the traffic light. Red for stop, yellow for slowing down, and green for go. So the red LED is connected to GPIO2 and our Raspberry Pi 4, which is then connected to a 220 ohms resistor connected to the ground terminal of our breadboard. The yellow LED is connected to GPIO3 of our Raspberry Pi 4 connected to a 220 ohms resistor connected to the ground terminal of our breadboard. Lastly, our green LED is connected to GPIO 4 of our Raspberry Pi 4 and is connected to a 220 ohms resistor connected to the ground terminal. The ground terminal is then connected to the ground port of our Raspberry Pi 4. So this is the circuit schematic. Same with the breadboard assembly. So the red LED is connected to GPIO2, which is connected in a serial manner to the ground. Next, the yellow LED is connected to GPIO3, which is again connected to a 220 ohms resistor connected to the ground. And lastly, a green LED, which is connected to GPIO4 and is connected to a 220 ohms resistor connected to the ground. So now, this would be the code of our experiment for first part of experiment number 7. So now I'll be opening our code saved in Thorny Python. So first, this would be the code for the first part of our experiment. So first, from GPIO0, import traffic lights. This would import the traffic lights library for our code. Next, from time, import sleep. So this would call out the sleep function. This would be importing the sleep function from the library. So first, we have named the variable lights for the traffic lights, and the parentheses shows which ports would be used for the green, amber, for the red, amber, and green light. So 2 is for the red, 3 is for amber, and 4 is for green. So initially, lights dot green on, which means that the green light would remain on, and after that, the loop would occur. So the green light would be on for 10 seconds, and after that, the green light would turn off and the amber light would turn on for 1 second. So after 1 second, the amber light or the yellow light would turn off and the red light would turn on for 10 seconds. And after that, the yellow light would turn on for 1 second along with the red light and the yellow light. Next, after that, the red light and the yellow light would turn off and the green light would turn on. So the process repeats. The green light would be turned on for 10 seconds and the loop repeats itself. So after showing you the code for the first part of this experiment, I will now click run, and let us observe the results for part 1 of our experiment, which is about building a traffic light. So as we could see, the green light stays lit for 10 seconds. Now let's wait. After that, the yellow light lights up for 1 second, and afterwards the red light lights up for 10 seconds. After that, both the red light and the yellow light will light up for 1 second, and the cycle repeats again. The loop repeats where the green light lights up for 10 seconds, and as I've said earlier, the loop will repeat. So that is it for our first part of the experiment. So after that, we will answer the question for the observations part of part 1. Does the given source code works properly as a traffic light system? The answer is yes, because it gives time for each interval of the light. So initially, it shows the green light, then afterwards, the yellow light. So after 10 seconds of turning on the green light, it turns off, and the yellow light will turn on for 1 second. And after that, the red light will turn on with the yellow light turned off for 10 seconds. And afterwards, the yellow light will turn on for 1 second. And after that, the green light will turn on again, and the cycle repeats. So therefore, we could say that it is a traffic light system, because a traffic light gives interval for each light that it gives. So for example, it gives a specific time for go, and for ready, which is the yellow light, and for stop, when it signals the red light. So afterwards, let's go to part 2. This would be the circuit assembly, and this would be the code which is inserted. So first, let us discuss the circuit assembly. Let's go to Fritzing. So as we could see, the circuit assembly is the same with part 1 as well as the schematic. So now let us go to the code. So this would be our code for part 2 of our experiment. So first, we import traffic lights from GPIO0. Next, from time, we import sleep, and from signal, we import pause. So again, we created a variable light with traffic lights. And then we have determined the ports to be used. For the red light, it is 2, yellow light 3, and green light 4. So this would be a function, traffic light sequence. So while true, yield 0, 0, 1. So meaning, for the first 10 seconds of the loop, red light is off, amber is off, and green light is on. Afterwards, for the next 1 second, red light is off, amber light is on, and green light is off. And afterwards, for the next 10 seconds after that, the red light is on for 10 seconds, and the amber light and the green lights are both off. And lastly, for 1 second, the red and amber light are both on, while the green light is off for 1 second. So that is the function, and the lights.source code calls out our function, traffic light sequence. So and we end the code with pause. So after showing you the code for part 2 of our experiment, let us click run and observe the results. So as we could see, the code used for part 2 of our experiment yielded the same results with part 1 of our experiment, wherein green light would light up for 10 seconds, yellow light for 1 second, and the red light would light up for 10 seconds. And after 10 seconds, the red light and the yellow light would light up for 1 second. for 1 second, and the green light would light up for another 10 seconds, and the loop repeats. So after that, we will answer the observation question. Does the given source code works the same in the given code in procedure 2? The answer is yes, since it gave the same interval and the same sequence of light for all the lights of the traffic light. So first, for the green, it turns on for 10 seconds, and afterwards it turns off with the amber light turning on for 1 second. Afterwards, the red light would turn on for 10 seconds with the green and amber light off. And lastly, for the next 1 second after the red light, the red light and the amber light would light up at the same time for 1 second, and the cycle repeats itself. So after that, let's move on to part 3 of our experiment. So the goal is to create a two-way traffic light system. So here, this is the circuit assembly, and this will be our Python code. So first, let us go to Fritzing to discuss the circuit assembly. So here, I have prepared 2 breadboards for this part of the experiment. So the first breadboard has the same configurations with part 1 and part 2, and I will only discuss this part. So for the second breadboard, this would be our second traffic light, and this would be our first traffic light. So the second breadboard is our second traffic light. So the red LED is connected to GPIO 17 with a 220 ohms resistor connected to the ground. Next, the yellow traffic light is then connected to GPIO 27 with a 227 ohm resistor connected to the ground. And lastly, the green LED is connected to GPIO 22, which is also connected to a 220 ohms resistor connected to the ground. As we could observe here, the grounds of both breadboards are connected, since there is a common ground between the two systems. So now let us move on to the schematic diagram. So it is the same. The first red LED is connected to GPIO 2 with a 220 ohms resistor connected to the ground. Next, the yellow LED is connected to GPIO 3, which has a 220 ohms resistor connected to the ground. Next, GPIO 4 is then connected to the green LED. So for the first 3, these are the LEDs for traffic light 1. Next, for traffic light 2, the red LED is connected to GPIO 17, and the yellow LED is connected to GPIO 27, and the green LED is connected to GPIO 22. All have 220 ohms resistor connected to the ground. So let us now move on to the code for part 3 of our experiment. So this would be the code for part 3 of our experiment. So since there are 2 traffic lights, I have created 2 functions using the traffic light sequence code we have used for part 2 of this experiment. So first, from we import the parts, same with part 2, traffic light, sleep, and pause. Next, we name the first variable traffic lights 2, 3, 4, since this would be used for traffic light number 1. So the same. So for traffic light number 1, we have named the function traffic light sequence 1. So while true, yield 001 for green 1, green 1, it would light up for 10 seconds. Next, the amber light would light up for 1 second with the red and green light turned off. Next, the red light would turn on for 10 seconds with the amber and green lights turned off. And afterwards, the red and amber light of traffic light number 1 would turn on for 1 second. So light source, this calls out our first function, which is traffic light sequence 1. Next, I've named another variable for lights, traffic lights. We would be using pins 17, 27, and 22 for traffic light number 2. So it has the same framework for the code. So first, we make the function traffic light sequence 2. So I have made traffic light number 2 the reverse of traffic light number 1. So I will explain. So first, yield. So since traffic light number 1 is on green, traffic light number 2 should be on red. So it shows that red light would turn on for 10 seconds with the amber and green light turned off. Afterwards, since before going green, the red and amber light would light up for 1 second. So I made it that way. So the red and amber light would light up for 1 second with the green light turned off. So next, since at the third yield, the red light for traffic light number 1 is on, so the green light for traffic light number 2 would be on. So the red and amber lights for traffic light number 2 are off, and the green light for traffic light number 2 is on for 10 seconds. And lastly, after showing the green light, the amber light would always show up for 1 second. So this is it for the fourth yield for traffic light number 2. Red light and the green light are off. Lights are off, and the amber light or the yellow light would turn on for 1 second. So this would call out the second function, traffic light sequence 2, and we end it with pause.
So before clicking run, this breadboard would serve as traffic light 2, and this breadboard would serve as traffic light number 1. So now I will click run. There, so we could see initially traffic light 2 shows stop while traffic light 1 shows go. After 10 seconds, traffic light 2 shows go while traffic light 1 shows stop. So we could see after an interval of 10 seconds, after going through go, the yellow light would light up. On the other hand, after going through stop, both the red light and the yellow light would light up for both traffic lights. There. So I have made it this way so that when traffic light 1 is on go, traffic light 2 would show stop to prevent accidents, so no crashing of vehicles would occur. And the same happens for when traffic light 1 is on stop and traffic light 2 is on go, so no accidents would occur for the vehicles using the road.
So for the last part of this experiment, part 4, the goal is to create a one-way traffic light system with pedestrian button control. So this would be our circuit assembly, and this would be our circuit. So let's head to Fritzing to discuss the circuit assembly for this part of the experiment. So here, so there. In the breadboard attached are 4 LEDs. This would the red LED, yellow, and green LEDs would be for the traffic light, and the blue LED would be for the pedestrian sign for crossing. So first, the red LED is connected to GPIO2 with a 220 ohms resistor connected to the ground. Next, the yellow LED is connected to GPIO3 with a 220 ohms resistor connected to the ground. Next, the green LED is connected to GPIO4 with a 220 ohms resistor connected to the ground. And lastly, our blue LED has a 220 ohms resistor connected to the ground, and the blue LED is connected to GPIO27. Next, our push button. The push button is connected to GPIO17 with the other side connected to the ground. Then, the ground terminal of our breadboard is connected to the ground port of our Raspberry Pi. So this is the circuit schematic. It it shows the same parts that I have discussed earlier. So this is the red LED connected to GPIO2, yellow LED connected to GPIO3, and green LED connected to GPIO4. The push button is connected to GPIO17, and the blue LED is connected to GPIO27. So now let us head to the code. So this would be our code for part 4 of our experiment. So first we input from GPIO0 import button, LED, and traffic lights, since we would be using these three functions or commands for this code. Next, from time we import sleep for the delay. Next, for the lights, same with before, I've created a variable called lights with for the traffic lights, which is at pins 2 for the red, 3 for yellow, and 4 for green. Next, for the LED, we will use pin 27, and for the button we would use pin 17. So initially the lights that green on shows that the green light would turn on indefinitely until the button is pressed, which is here. Button, wait for press. So if the button is pressed, the green light would turn off and the amber light would turn on for 2 seconds. Afterwards, the LED or the blue light would turn on, and the red LED would turn on, with the green lights and amber lights turned off for 5 seconds. This would be the time for the pedestrians to cross the pedestrian crossing. So next, before the green light turns on again, the LED would blink. So this would be the interval 0.1 seconds on, 0.1 seconds off for the 2-second delay. So this would serve as the warning for the pedestrians that the time for crossing is over. Next, upon releasing the button, this would be read by the code as button wait for release. Upon releasing the button, the LED would turn off and the red light would turn off too, also the amber light, and the green light would turn on for 5 seconds, and this would go indefinitely until the button is pressed again, which would repeat the loop.
So after showing you the code for part 4 of our experiment, let us click run and observe what happens with the circuit. So this would be our traffic light, and this would be the light that signals the pedestrians to cross the road. So when I press the button, there, the yellow light would first warn the vehicles to stop, and then the red light and the blue light would light up. So let's do it again. There, the yellow light and the blue light would light up, showing that the vehicle should stop. And when the blue light blinks, it warns the pedestrians that the crossing time is over, and the traffic light would signal go. So let us do it again. So when the blue light is lit, pedestrians can cross the road, but if it's off, the vehicles on the road are signaled to go, and the pedestrians should stop at the sidewalk, at the pedestrian crossing. So let's do it again. There. So we could set the code to make the pedestrian crossing faster, but in the case of this experiment, we can only observe the results of the code, and it is the delay or the sleep time for this two LEDs can be easily set. So if we want to make it longer, we could easily change the amount of time that the red light and the blue light are on. So that is it for our experiment number 7 for Internet of Things Laboratory.